Project Management Professional Training Session 14 Part B. In the following, we will discuss this process in the form of steps. 1. Get how-to information. First, find out from the Resource Management Plan general information on how to use, control, and release the physical resources. 2. General resource information. From the Resource Requirements in RBS, find the reference for detailed resource information. This information will be useful in case a resource needs to be replaced or an additional quantity of it needs to be acquired. 3. Get process facilitators. While performing this process, be aware of risks attached to the resources. These risks are recorded in the risk register. Also, continually use the Lessons Learned register to record the lessons learned during this process for subsequent use. Moreover, agreements made are recorded into documents when issues arise with the resources in use or when new resources are acquired during project execution. Here, we are talking about the resources external to the organization. 4. Get information about scheduled and assigned physical resources. The project schedule reveals the needed resources, which resource and when and where it's needed. These are planned resources. Physical resource assignments contain information about the resources assigned to the project, resource type, quantity, assignment location, and whether the resource is internal or external to the organization. These are allocated resources. 5. Get the used resource information. Work performance data provide information about the actually used resources, such as the resource type and quantity used. 6. Synchronize planned, allotted, and in-use resources. In steps 4 and 5, you got information about planned, allotted, and used resources. Having this information, you can do the following. A. Conduct performance reviews. Compare and analyze the actual resource usage from the work performance data with planned and allotted resource use to prepare work performance information, an output of this process. This would expose any asynchronization or gaps between planned, allotted, and used resources. You then proceed to synchronize the planned, allotted, and used resources triangle. B. Predict the resource usage. Perform a trend analysis on the work performance data collected over time to predict the resource usage in the future. Knowing the predicted resource usage, you would want to synchronize it with the planned and allotted resources, as shown next. C. Explore different solutions. You deal with shortages and surpluses of resources by adjusting cost/budget, scope, schedule, or a mixture of these three factors. You can perform a cost-benefit analysis, covered in Chapter 7 on cost management, to explore the option of acquiring additional resources in case of shortage. Also, you can consider the other options to synchronize predicted resource usage with the planned and allotted resources, such as adjusting schedule or scope. D. Pick the best solution. You pick the best options by performing alternatives analysis and then generate the change requests accordingly, another output of the control resources process. E. Use your negotiation and influencing skills to get the best solution approved. F. Based on approved and implemented changes, or for other reasons in this process, update the documents that need to be updated, e.g., those listed in the output column of Table 13.5. While controlling resources, you can also use the problem-solving technique, which is listed in PMBOK as a technique for the control resources process. However, it is a very general approach that can be used in all disciplines of knowledge. This approach is applied to solve a problem by taking the following steps. 1. Identify and define the problem clearly. 2. Break the problem into smaller, easily solvable pieces. 3. Investigate the problem and collect data. 4. Analyze the data to discover several possible solutions. 5. Choose the best or most suitable solution. 6. Test the chosen solution to make sure that it fixes the problem. Study Checkpoint 13.4. Using your knowledge of organizational project assets and the control resources process, answer the following questions. Q1. Make a list of OPAs that would influence this process. Q2. How might the assumptions log and risk register be updated as a result of the control resources process? Project cost and budget depend on project resources. So, controlling project resources and controlling cost are related. Once the project cost is determined and the budget is approved, as discussed in Chapter 6, you need to control the cost as the project progresses. Controlling cost. Controlling cost means monitoring and controlling the cost performance and the resulting updates and changes to the project's cost, budget, and cost baseline. Monitoring and controlling cost has two dimensions: expenditure of project funds and the work performed as a result of those expenditures. One major aspect of cost monitoring and controlling is to determine the relationship between the expenditures and the accomplishments. The cost performance lies in this relationship. The other main aspect is to control changes to the approved cost performance baseline. Caution: like any other change, a change in cost and budget must also be processed through the integrated change control process and should only be implemented after its approval. To be more specific, monitoring and controlling the project cost includes the following. Influence the factors that can create changes to the approved cost baseline. Monitor the following. Work performed against the funds expended. Variance of cost performance from the approved baseline. Prevent unapproved changes from creeping into implementation, expenditures, and cost reports. Act to keep cost overruns within the planned acceptable limits. Ensure the following. Change requests are dealt with in a timely fashion and managed as they occur. Expenditures do not exceed the approved budget, that is, by period and by total amount. Any change to the budget must be approved before implementation. Communicate with the appropriate stakeholders about the cost associated with the approved changes. Cost is monitored and controlled by using the control costs process, which is presented in Table 13.6 in terms of input, tools and techniques, and output. Table 13.6. The control costs process: input, tools and techniques, and output. Input, tools and techniques. Output. 1. Project management plan. Cost management plan. Cost baseline. Performance. Measurement baseline. 2. Project funding. Requirements. 3. Work performance data. 4. Project documents. Lessons learned register. 5. Organizational project. Assets. 1. Earned value analysis. 2. Variance analysis. 3. Trend analysis. 4. Reserve analysis. 5. To complete. Performance index. 6. Project management. Information system. 1. Work performance. Information. 2. Cost forecasts. 3. Change requests. 4. Plan updates. Cost management plan. Cost baseline. Performance measurement. Baseline. 5. Updates to project. Documents. Cost estimates. Basis of estimates. Assumptions log. Risk register. Lessons learned register. The following steps are the core of the control cost process. 1. From the cost management plan, get information on how to control cost. Apply this information to the following steps. 2. Compare the cost results from project execution in the work performance data against the cost baseline by using variance analysis. If deviations pass the threshold, create needed change requests. 3. Perform the earned value analysis by comparing the project execution results in the work performance data against the performance measurement baseline. This comparison may generate change requests. 4. Based on these comparisons, perform the trend analysis. This will generate the cost forecast. 5. The results from the preceding steps will create work performance information. 6. Like in many other processes, use the lessons learned register to record and subsequently use the lessons learned to improve the process. Organizational process assets that can influence cost controlling include cost control-related policies, procedures, and guidelines, monitoring and reporting methods, tools used in controlling cost, and the lessons learned database from past projects. Caution. In general, project progress or performance is measured by comparing the project execution results, found in the work performance data, against the performance measurement baseline, which is an approved integrated plan for scope, schedule, and cost for the project. Important relevant components in this integrated plan are scope baseline, schedule baseline, and cost baseline. Two common input items to controlling scope, schedule, and cost are work performance data and performance measurement baseline. In all three processes, we perform performance measurement analysis, using some tools and techniques, to generate work performance information, a common output item of these three processes. The elaborate nature of the performance measurement analysis can be seen in the cost control process. This performance measurement analysis for cost control, using the tools and techniques listed in Table 13.6, is presented in the next section. Performance measurement analysis for cost control. As mentioned earlier, cost control includes influencing the factors that can create changes to the cost baseline. But to detect the arising changes, you need to detect and understand any variances or deviations from the cost baseline by monitoring cost performance. In general, a variance is a measurable deviation in the value of a project variable or parameter, such as cost or schedule, from a known baseline or expected value. Variance analysis is a technique used to assess the magnitude of variation in the value of a variable, such as cost from the baseline or expected value, determine the cause of the variance, and decide whether a corrective action is required. A common technique used to assess the cost variance is called the earned value technique, EVT, also called earned value management, EVM. It is a commonly used method of performance measurement that has various forms. Most commonly, it integrates the scope, schedule, and cost performance by comparing the baselines with the actual progress made. For example, you calculate the cumulative value of the budgeted cost of work performed in terms of the originally allocated budgeted amount and compare it to the following. 1. Budgeted cost of work scheduled, that is, planned. 2. Actual cost of work performed. Don't worry if these terms sound confusing right now, I will go through an example soon. However, as you will see, the greatest difficulty in understanding EVT, or EVM, stems from the coupling of cost and schedule. You must realize that the project cost and the project schedule are inherently related to each other. Schedule refers to performing certain work over a certain time period, whereas cost refers to the money spent to perform the work on a project, or a project activity, over a certain period of time. The relationship between cost and schedule can be realized by understanding that it costs money to perform a schedule activity. Also, the time is money principle is at work here. For example, a project activity can be looked upon in terms of an amount of work that will be needed to complete it or in terms of its monetary value, which includes the cost of the work that needs to be performed to complete the activity. Caution! As you delve into EVM, remember that there are only three variables or parameters that need to be monitored and developed closely: planned value, PV, earned value, EV, and actual cost, AC. The rest of the parameters and the earned value analysis are largely based on these three fundamental parameters. The EVM involves calculating some variables where you will see the interplay of schedule, work, and cost. I will work through a running example to help you understand the terminology used here. Example: assume you are a project manager for the construction of a 16-mile road. Further assume that the work is uniformly distributed over 12 weeks. The total approved budget for this project is $600,000. At the end of first 4 weeks of work, $125,000 has been spent, and 4 miles have been completed. I will use this example to perform the cost performance analysis and the schedule performance analysis in terms of cost. Cost performance. Cost performance refers to how efficiently you are spending money on the project work, measured against the expectations set in the project management plan, that is, the cost baselines. The total cost approved in the baseline is called the budget at completion, BAC. Note the variables discussed here, such as BAC, EV, and AC, can be calculated either for the whole project or for a part of the project, such as a project activity, budget at completion, BAC. This is the total budget authorized for performing the project work, or a project activity, also called the planned budget. In other words, it is the cost originally estimated in the project management plan. You use this variable in defining almost all the following variables. In our example, the value of BAC is $600,000. Earned value, EV, or budgeted cost of work performed, BCWP. This is the value of the actually performed work expressed in terms of the approved budget for a project or a project activity for a given time period. In this variable, you see the relationship of schedule, work, and cost in action. BAC represents the total value of the project. But when you perform only some work on the project, you have earned some of that total value, and the earned value is proportional to the fraction of the total work performed, as shown by the formula here. EV equals BAC times work completed / total work required. So, in our example, EV can be calculated as EV equals $600,000, 4 miles per 16 miles, equals $150,000. This is the earned value of the work performed so far, which may or may not be equal to the actual money that you spent to perform this work. Actual cost, AC, or actual cost of work performed, ACWP. This is the total cost actually incurred performing the work for a project until a specific point on the timescale. In our running example, $125,000 has already been used up to this point. So, the actual cost at this point in time is $125,000. This cost is to be compared with the earned value to calculate the cost variance and cost performance. Cost variance, CV. This is a measure of cost performance in terms of deviation of reality from the plan. It is obtained by subtracting the actual cost, AC, from the earned value, EV, as shown in the formula here. CV equals EV AC. So, in our example, CV can be calculated as shown here. CV equals $150,000 to $125,000 equals $25,000. The expected value of CV is 0 because we expect the earned value to be equal to the actual cost. The positive result indicates better cost performance than expected, whereas a negative result would indicate worse cost performance than expected. Deviation is one way of comparison, and ratio is another. Cost Performance Index, CPI. Earned value represents the portion of the work completed, and actual cost represents the money spent. So, the CPI indicates whether you are getting a fair value for your money. This is a measure of the cost efficiency of a project calculated by dividing earned value, EV, by actual cost, AC, as shown in the formula here. CPI of AC equals. So, the CPI for our example can be calculated as CPI equals $150,000 / $125,000 equals 1.2. This means you are getting $1.20 worth of performance for every dollar spent. A value of CPI greater than 1 indicates good performance, whereas a value less than 1 indicates bad performance. The expected value of CPI is 1. Back in our example, both the CV and the CPI indicate that you are getting more value for each dollar spent. Hold back a little before opening the champagne, though. If you read the text of our example again, note that 4 out of 12 weeks have already passed, and only 4 out of 16 miles of road have been built. That means that only 1/4 of the work has been accomplished in 1/3 of the total scheduled time. This means we are lagging behind in our schedule. Although cost performance is good, schedule performance needs to be investigated, too. Remember, time is money. Schedule performance in terms of cost. Schedule performance refers to how efficiently you are executing your project schedule as measured against the expectations set in the project management plan. It can be measured by comparing the earned value to the planned value, just like cost performance is measured by comparing the earned value to the actual cost. Planned value refers to the value that we plan to create in the time spent so far. Planned value, PV, or budgeted cost for the work scheduled, BCWS. This is the authorized cost for the scheduled work on the project or a project activity up to a given point on the timescale. The planned value is also called the budgeted cost for the work scheduled, BCWS. PV is basically how much you were authorized to spend in the fraction of scheduled time spent so far, as shown in the formula here. PV equals BAC times time passed / total schedule time. Therefore, the planned value for the project in our example at the end of the first 4 weeks is calculated as shown here. PV equals $600,000 times 4 weeks / 12 weeks equals $200,000. So, PV represents the planned schedule in terms of cost. You can calculate the schedule performance by comparing the planned schedule to the performed schedule in terms of cost. Caution! Note that the total planned value, PV, of the project is the same as the budget at completion, BAC. Schedule variance, SV. This is the deviation of the performed schedule from the planned schedule in terms of cost. No confusion is allowed here, because you already know that the schedule can be translated to cost. SV is calculated as the difference between EV and PV, as shown in the formula here. SV equals EV, PV. So, the SV in our example can be calculated as SV equals $150,000 to $200, 000 equals minus $50,000. The negative value means we are behind schedule. Deviation represented by schedule variance is one way of comparison, and ratio represented by schedule performance index is another. Schedule Performance Index, SPI earned value represents the portion of work completed in terms of cost, and planned value represents how much work was planned to be done by this point in time in terms of cost. So, the SPI indicates how the performed work compared to the planned work. This is a measure of the schedule efficiency of a project calculated by dividing earned value, EV, by planned value, PV. As shown in the formula here, SPI EV PV equals so, the SPI for our example can be calculated as shown here, SPI equals $150,000 / $200,000 equals 0.75. This indicates that the project is progressing at 75% of the planned pace, not good. You should note that all these performance variables except the BAC are calculated at a given point in time. As shown in Figure 13.3, you can maintain a graphic that presents the values of these variables against points in time as the project progresses. Note that the value of the BAC does not change with time because it is the cost at completion time. Further note that, given the BAC, the PV can be calculated at any point in time, even before the project execution starts. EV and EC are accumulated as the project execution progresses. By using the variables discussed so far, you can monitor the project performance as time progresses. Not only that, but you can also make predictions about future performance based on past performance. Figure 13.3. The behavior of some performance variables as the project progresses in time. The variable BAC is independent of time.